Okay, right. Welcome to practice test 21, paper 1H mark scheme. Let's speed run today, so let's do this quickly. Right, number one. Expand and simplify this, so that times out n squared, that times out 4n, positive 4n, that times out negative 6n, and that times out minus 24. Don't forget to collect the middle two terms. We've got a plus 4 and a negative 6. That's going to be n squared minus 2n minus 24 for the first question. Now, solving this, the first thing you want to do is to multiply your 4 across. Don't forget to use brackets here. 4 bracket 2x minus 3 equals 3x minus 5. Expand your bracket. 8x minus 12 equals the same thing. Move the x's to the left, so that 3x on the right becomes negative 3x, and that 12 on the left becomes positive 12. Sort the left out, 5x, sort the right out, 7. X divided by 5, so 7 fifths, or you can write 1.4 if you want. Next question, number 2. Probably he's going to use a treadmill 0.8. When he uses a treadmill, probably he will use a cross trainer 0.3. When he does not use a treadmill, which has to be 0.2, they have that up to 1. Probability they use the cross trainer 0.6. Okay, so each pair of branches added up to 1, so this one's going to be 0.7, this one's going to be 0.4. So that's part A, I've done it. Work out probably Rudolph uses both treadmill and the cross trainer, so that and that times those two together, 0.3 times 0.8. The way I remember is that you're going to borrow one decimal place there, one there. 3 times 8 is 24. Give your two decimal places back, so go 1, 2, decimal point there, 0.24, bam. That's the answer. Number 3, in standard form, right? So think about it. First number has to be between 1 and 10, so it's definitely going to be 8.9. I put the decimal place there. And you need to move it 5, 1, 2, 3, 4, 5 to the right, so and because it's a smaller number, it'll be 10 to the negative 5. That's the answer. This, again, remember, is a 1 followed by 4 zeros, so move that decimal point 4 places to the right. So you will need 2 zeros as placeholders, because obviously it moved from there, 1, 2, 3, 4 places to go there. So that's the answer, no decimal place, obviously, in the answer. Factorize, right, we want to remember team. What two numbers times to give negative 24 and add to give 5? Well, I know that 24 is 8 times 3, and I also know 8 and 3 are 5 apart, so I know it's going to be a combination of those. I've just got to pick the right sign. Now, the right sign is a positive 8 and a negative 3, because if you add these two, you still get positive 5, and if you times, you get negative 24. So in brackets, you've got x plus 8, x minus 3, job done. Right, solving that, hence, any question with hence means part A will greatly help you. Right, remember, what this is saying is that equals 0. So remember, how do we make each bracket 0? And that's the answer. Well, this one, x would have to be negative 8, and this one here would have to be positive 3. So the answers are 8, minus 8, sorry, or 3. Moving on, right, we're doing this quickly today. Right, show that. So write these two numbers as improper first. So this one will be 16 thirds. This one will be 20 sevenths. Common denominator here is going to be 21. So times the left side by 7. So 16 times 7. 6 sevens are 42. Carry the 4. 112. And this times 3. This one's easier. 60. 112 take away 60 is 52. Over 21. You guessed it. It's got to be, well, it goes in twice, remainder 10 over 21, which is the thing you're asked to show. Done. Number 6. Right, we know the median is right, actually, no, right, which place to start is the best question to ask here. So the mode is 9. Now notice they use the same letter at the end 3 times, that's the mode, so that's going to be 9. So our list will end 999. Now the median's 8. When there's two numbers in the middle, the median's the one in between them both. So 8's halfway between 9 and what other number? Has to be 7, doesn't it? So we know what C is now. C is 7. The range is 4. So 9 take away what number equals 4 is going to be a 5. So that's the smallest number, 5. And because we're told that this inequality, they're sort of increasing in size. Well, the only number bigger than 5 and less than 7, which is an integer, that's a whole number, is 6. So that's your answer, 567,999, Dan. Number 7, solve the simultaneous equation times this one by 3. 9x take away 3y equals 21. Add the first and the third equation together, because you want to cancel the 3y's out. 16x equals 24. divide 24 by 16, which simplifies to 3 over 2. You just divide them by 8. That's 1.5. And we can substitute in to work out y. You know what, I'm going to pick that third equation, so 3 lots of x, 1.5. Take away y, 7. So that's what 4.5 take away 7 is. Sorry, 4.5 take away y is 7. Move your y over. So you'll get 4.5. The y, because I'm moving it to the right, becomes positive. The 7 becomes negative. B minus 2.5. So x is 1.5. Y is negative 2.5. You can use improper fractions. If you wrote 3 halves for x and 5 halves for y, negative 5 halves for y, you're fine. Right, here, drawing these lines. Okay, right, for this one we've got to draw all 3 straight line graphs. So let's start with y equals 1. That's the y line going across like that. Again, you would use a ruler, but I'm on an iPad here. X equals 2 is the blue line there. And the last one's a bit tricky, right? Basically, this means all the points where the x and y coordinates add up to 7. So you can just pick any point, for example, 1 and 6 add up to 7, 2 and 5, 3 and 4, etc. And you'll notice there's this diagonal line going like that, because anywhere you put your finger on that line, the x and y coordinate at that specific point will add up to 7. So that's part A done. Now this question says, find the region that satisfies all 3 inequalities. Okay, right, so we are in the middle of this inequalities question. To finish up with, we want the area that's greater than 1, y is greater than 1, x is greater than or equal to the 2, and x and y is less than or equal to 7. So looking at it this way, y is greater than 1 is above this green line, x is greater than 2 is to the right of this line, and this, basically add your x and y coordinates to be less than 7 will be that side of the purple line. So which area do all of those 3 conditions, where are they all satisfied? It's this area here, isn't it? So shade that in and label it R. In fact, you don't need to shade it in. In fact, from an examiner standpoint, don't just make it very clear R. Try not to shade it because the R may not be visible. Maybe on number 9, simplify. Now, anything to the power of 0, and be careful, it isn't going to be 4 because the 4 is also within the brackets. So all of that to 0 is 1. The 4 becomes a 1 as well. So 8 times 1 is 8, is that one. Here, find the value of p. Well, the first thing I want to do is let's deal with dividing this. So x to the 6 divided by x to the negative 5 will be, well, if you're dividing powers, you subtract them. We are going to get a double negative here because we're subtracting negative 5. So the left-hand side is going to become x to the 11. And that's equal to xp. Now, we do need to divide both sides by the x. So p is actually x to the 11 divided by x. Or you can think of it as x to the power 1. So look, we're dividing 11 by 1, meaning we take it away. X to the 11 take away 1 is x to the 10. And that is your answer, x to the 10. Now, simplifying fully this, to the power of 3, you've got to raise all 3 terms to the power of 3. So imagine 2 is 2 to the power of 1. We're going to times the 1 by 3, 2 cubed. The squared is going to get times by the 3 as well. And the m, the 4 times 3 as well. So 2 cubed we know is 8. So the 2 cubed becomes an 8. The k squared times 3, that becomes k to the 6. And lastly, the m becomes m to the 12. Moving on. Here is a table. Cumulative frequency table, remember it's a running total. The first number is always the same, but you just add the next number along. So 7 plus 25 is 32. 32 add 20 is 52. Add 14 gets it to be 66. And add 8, you get 74. And then obviously add the last one, you get 80. Now, the question does say 80 people, so seeing 80 as my last number is reassuring. And then we've got to draw a cumulative frequency graph. So remember, with cumulative frequency graph, these are all your x coordinates. And then these are all your y coordinates, right? So these are all my x's, these are all my y's. So the first coordinate I'll plot is 20 with the number 7. So 20 on the x, 7 on the y. There, be accurate, 20 and 7. Followed by 30 and 32. 30, 32. 30, 32 is up here. Just, make sure you don't make any mistakes with the scaling. 40 with 52. 40, 52, be accurate. Last couple now. 50, 66, which is up there. Next up, we've got 60, 74, and 80, we've got 80. 70, 80, sorry, 70, 80. So that's all the way up here. Now, with the cumulative frequency graph, always think about this. Your graph should start at 0, because there's nothing, that's the smallest possible age. So do a smooth curve, crossing all your points, like I'm doing. Freehanders, do not use a ruler, otherwise you will lose marks. Make sure your curve, it can wibble and wobble, but it has to go through all these points I've just plotted. So that's a perfect one. Now, I need the median. So this is continuous data. I know that some people say add 1, divide by 2, but when the data is continuous, like people's age, we just divide it by 2. So n, because there's 80 people, I always halve that for continuous data. There's no need of +1. That's only for discrete. You go across and down. So the answer, the median I'm getting is approximately 33. Again, you are allowed, I would probably say anything that's 32, 33, 34 would be accepted. Sorry, I've just answered the wrong question. This is part C. Beg your pardon, 33 years there. And of course, the last question of the people in the train carriage, 60% of those who are aged between 18 are not going to work. None of the other people in the train carriage are going to work. Use your graph to find an estimate for the number of people in the train carriage who are going to work. Okay, so how many people basically are on this train between 18 to 65? So let's see, right, 18 gives me 6. Basically, there are 6 people on the train that are less than 18 years old. And there are 60, let me find 65, which is here. So again, usually I would use a ruler, but on an iPad, this is a little bit difficult, but you get the idea. Go up and across. And basically, we're saying that there are exactly, be accurate, what is this? 70. Yeah, there's about 77 people that are 65 or below. So we want to do, there are 77, 65 or below people. There are also 6 18-year-olds and under. So how many people are aged between 65 and 18? Well, just take the numbers away. So I'm getting 71, beg your pardon. So basically this question is saying 60% of this many people are going to work. So in other words, what's 60% of 71? Well, 10% would be 7.1. So 60% would be 6 lots of this. So what's that? 70. You're going to get 42.6. So my estimate is going to be like 43 people. But of course, the mark scheme would probably allow, people that are, round up or down. Let me just look at the mark scheme really, really quickly. While that loads, I'll crack on with the next question. So let me come back to that in a minute. We're now on number 11. Right, Venn diagrams always start from the very, very center. So they're bamboozling you with numbers. Always go with the very center where all 3 meet. So that's 6 in the very center. Then obviously look at the overlap. So with Venn diagrams, always start from the middle and work your way outwards. Sheep and goats. So sheep and goats is the top bit. Now, if they both add up to 11, that has to be 5. Because remember, the middle is included within this 11. So 5 people have goats and sheep, but not chickens. 17 have sheep and chickens. So sheep, chickens, that's going to be 11 because they have to add up to 17. 18 have goats and chickens, meaning this has to be 12, right? Because 12 and 6 have to add up to 18. Where are we now? We've got 20 don't have any, so that goes on the outside. 53 have chickens. So all 4 areas of the chickens adds up to 53 chickens. So we'll add the 12, 6 and 11 together, giving us 29, and take that away. So this would be 24 for just this, the chickens, and 31 have sheep. This bit you probably do in your head. 9, I believe. And to work out the last missing section, you do have to add all these up and take away the answer from the total, which we're told is 100. So we are going to need to add the 20, the 9, the 5, the 6, the 11, the 12, and 24. This is going to be tricky. Don't make mistakes now. So you're going to get 10, 21, 27, KO2, 2, 4, 6, 87. I'm getting 13. So 100 take away 87. 13. I will confirm this with the mark scheme, but that should be the completed Venn diagram. Let me just rewind to the previous question. Yeah, so for part B, they just rewinding to this one here, they do accept any answer between 39 to 43. That's in the mark scheme, so 43 as well within that. This one here, Venn diagram, I'm just looking at it now, is correct. So no changes needed there. Number 12, nth term. With nth term, always look at what your sequence is going up by. This one increases by 4, so it'll be 4n, right? But there's always a number you add on at the end. I always say find a 0 term. So if we had to find one number before the 1, imagine this sequence started 1 term earlier. Well, if you wanted to continue this pattern, it would have to be a -3, wouldn't it? Because it would go -3, plus 4 would be 1, plus 4 would be 5, and so on. So the -3, we call this the 0 term, is usually what you add on after you've identified the 4n part. So 4n minus 3. 1 mark for each of those, correct. Okay, so notice how they've changed the letter N. Usually they would say nth term. So you would usually expect to see the letter N. Here you see 2m. Don't be scared by this. Basically they're saying replace the letter N here with 2m. So just do that. So 3 bracket 2m, because I've replaced the letter N with 2m, plus 5. Expand this out, you get 6m plus 5. So that was part B. Also 1 mark. Right, next go. Right, solve it. So a few ways you could do this. I'm going to put them all over the same common denominator. So I've noticed that both fractions, well, one's over 3, one's over 2. The lowest common multiple for both of those is 6. So I'll times the top and bottom by the first fraction by 2. So that would turn the first fraction to be over 6. Minus, and I'm going to do the same here, but I'm going to times this side, top and bottom, by 3. So this will still be over 6. It'll be 3 bracket 3 minus 2x. Remember, this equation is still equal to 13. Now, the benefit is now we can put this all over one common denominator, 6. So this bit will be 4x plus 10. Be careful with the negative here. It'll be minus 9. But because you're multiplying minus 3 by minus 2x, it becomes plus 6x. A lot of people are going to get that bit wrong in the end, so be really, really cautious. Right, so now what I would do, let me continue up here. We'll tidy up the x's, so the 4x and 6x add to give 10x. Your 10 and 9 minus 9 gives an answer of positive 1. Over 6 is 13. Times across your 6, so 10x plus 1 equals 13 times 6, which is 78. So 10x plus 1 is 78. So 10x equals 77. So x is 7.7. Don't know why I wrote x there because it's already in the answer line. Is 7.7 right? Let me check the answer. It most certainly is not. So where did I go wrong? It's saying here 5.5. Interesting. Let me backtrack. Where did I go wrong? Of course. Why on earth did I write 2x in the first bracket? Let me I don't have to change lots about this, but clearly I have made a mistake. So let me fix it. So this should have been times by 2, should have been 8x. So my apologies there, people. I did mess up. 8x. So, so this should have actually been 14x because 8 plus 6 would have been 14. Okay. So you can divide both sides of this equation by 7. 2x equals 11, so x is 5.5. My bad. I messed up there. Right, solve this inequality. This is challenging. So use your AC method. So AC, so A is 2, B is negative 7, C is negative 30. AC means 2 lots of negative 30, that's minus 60. And B is minus 7. I'm looking for two numbers that have a product of negative 60, meaning they times the 60 but add to give 7. I've got a feeling it's going to be not 6 and 10 because I can't make 7 by adding and subtracting 6 and 10. 20 and 3, no, that doesn't work either. 15 and 4, no. 12 and 5, 12 and 5, yeah, it's going to be 12 and 5 because they are 7 apart. It's going to be negative 12 and positive 5. Now, what to do with these two numbers? Once you've worked this out, basically you're going to split your negative 7x into 12x or minus 12x and plus 5x. That's the trick. That's the AC method. So let's rewrite that equation as 2y squared minus 12x plus 5x, because I've split the middle up, minus 30 is less than or equal to 0. Okay, next up, we're going to factorize in pairs. So factorize the purple pair. Common factor is, I can't believe I wrote x here and here. My bad. It is all y. I just made another mistake. What's going on with me today? Purple pair will be 2y as a common factor, bracket y minus 6. Blue pair, you get common factors 5, so plus 5 on the brackets, y minus 6. If you've done this correctly, you'll notice that both brackets are identical, which they are. So the y minus 6 goes in one of the brackets. What goes in the opposite one is what you got here and here. It's 2y plus 5. So put that in the bracket as well. Is less than 0. So this is a tricky bit. We remember each bracket we want to make equal to 0. So in order for the first bracket to be 0, you'd have y as 2.5, or you can write 5 over negative 2.5, sorry, or minus 5 over 2. And for this bracket, y is 6. These are not the solutions. These are called critical values because this is an inequality. Now, imagine I asked you to draw this graph. Any y-squared graph looks like a u. More specifically, this u shape is going to cross not my x-axis, but my y-axis. Do you know what? Let's keep it simple. Let's call that the y-axis and this the x. You can do this if you want, right? All I've done is switch the letter x and y around, really, haven't I? So look, if I was to draw this, because I switched the x and y around, it would look like this. My curve would go through minus 2.5 on that bit there, and 6 over here. When is this graph less than or equal to 0? When is it less than or equal to 0? Less than or equal to 0. It's here. Okay, if it was greater than 0, it would be here and here, but it isn't. It's the blue bit. So to wrap this up, when is this less than 0? It's when x is greater than or equal to negative 2.5, or x is less than or equal to 6. These are your answers. Minus 2.5, x is bigger than that, right? Because it's sort of on that side of negative 2.5, or x is less than or equal to 6. Tricky one, that. Number 14, triple brackets. We love, what's better than a double bracket? Triple bracket, triple up. So only focus on one pair first. I'm just going to expand and simplify this. So if I said the double bracket, 5 minus x and 2x plus 3, here's what you do. You times these two out, 10x. You times those two out, plus 15. You times those two out, minus 2x squared. And then you times those out, minus 3x. Let's tidy this up. The x's, the 10x and minus 3x, leaves you with 15 at the front, plus 7x because it's still a positive, minus 2x squared. Lovely jubbly. So what we can say is all of this is the same as writing this in brackets. And all we've got to do now is times it by x plus 4. So let's do that. So we need to multiply and all three terms by x. So what I'll do is I'll do 15x plus 7x squared, and then those two at the end minus 2x cubed, followed by, I'll choose a different color now. Let's choose green. I'm going to multiply the same three things now, but instead of x, I'm going to multiply it by 4. So 15 times 4 is 60, 7x times 4 is 28x, and minus 2x times 4, minus 2x squared, sorry, times 4 is minus 8x squared. So let's tidy this up. To wrap things up, I always like to put the x cubed term first. So always put the highest power first, minus 2x cubed. That's the only x cubed term, so fair enough. Followed by x squared. So we've got 7x squared minus 8x squared. That gives me a total of minus x squared. Moving on to the next term, blue, we'll just do the terms with x. I just realised something. When I did the first x term, when I did 15 at the beginning times x, I forgot to put an x there, so my bad. I would have got this wrong had I not spotted that. So let's get this right. So 15x plus 28x, that's going to be 43x. And then obviously there's the 60 at the end, which is sort of the only constant term, plus 60. Let me double check the mark scheme. But yeah, convention usually says start with the highest power, work your way down. Let me confirm that. I am happy to confirm that is the right mark scheme result. Make C the subject. Okie dokie, let's do that. All right, firstly, move the 7 over. So start with g plus 7 equals that fraction. So all I've done is I've sort of moved the 7 over, made it negative. Now what you want to do is get rid of fractions entirely. We're going to times your 4 plus c, use brackets here on both sides. You're allowed to do this. So on the right-hand side, because you're multiplying by the denominator, the top and bottom cancel out, leaving you with a c plus 3. On the left, you are going to have double brackets. So we'll have the g plus 7, but we're also times it, remember, by 4 plus c. So let's handle this double bracket. G times 4, 4g. G times c, gc. 7 times 4, 28. 7 times c plus 7c equals c plus 3. Okay, now because we want to make c the subject, move everything with c to one side and everything without c to the opposite side. You can pick a side. I'm just going to say move everything with c to the left side. So I can keep that here, the GC. I can keep that one too, plus 7c. But the c from here, I'm moving it over. It's going to become a negative because I'm moving it to the left-hand side. And obviously, we need to move everything without a c to the other side. So your 4g is going to get turned into a minus 4g because I'm moving it to the right. Your 28, you guessed it, minus 28. And the 3 stays there, right? It's not going anywhere. It's staying on the right. So have I got, yeah, everything with the c is on the left now. Everything without c is to the other side. Okay, we can do a bit of tidying here. These two simplify. So you've got gc plus 6c, because the 6 minus 1, c is 6, equals, well, your 3, you can say minus 4g. 3 minus 28 is minus 25. Right, to finish this question off, we've got all our c's on one side and everything without to the other. The trick here is, and the reason why we bring all the terms with c to one side is so we can factorize it. That is the main point, this is the main objective. So look, c bracket g plus 6, I've just factorized that, equals minus 4g, take away 25, and then we divide by the bracket, right? So c is negative 4g minus 25, all divided by g plus 6. Now what you can do is you can factor from the numerator the minus sign. Some people might have done this and written 4g plus 25. Again, that line there would be enough for 4 marks, g plus 6. There are variations of this that you could have written that would qualify you for 4 marks. So if you've got something else and you'd like me to have a quick look at that, I'm happy to do so. I'm just quickly pulling up the mark scheme and I will tell you. But while that loads, Let's look at question number 15. I will come back to that, promise. Right, so to find f10, we're just inputting 10 here. So 2 bracket 10 over 10, take away 6. What, 20 divided by 4? That's 5 is f of 10. Now, the inverse function, the way you find the inverse is we say, well, look, instead of calling it the inverse, let's say y equals 2x over x minus 6. Your job is to make x the subject. If you can do that, you have 1. So actually, a bit similar to the previous question, times across your bracket, so y bracket x minus 6 equals 2x. So this becomes yx take away 6y equals 2x. Move all your x's to one side. I'm going to move mine to the left and all your y's to the right side, or anything without an x to the right side. Factorize y minus 2 and then divide by the bracket. So x equals 6y over y minus 2. Now, the final step, which is a very important one, that is your inverse, but just remember to change all your y's back to x's, otherwise you'll lose a mark. So it's the same thing as what I've circled, but we change all the x's back to y's. Now, I did promise I would check the previous question while it loaded. It appears to have loaded, and I can hopefully confirm 14 is the right answer, which it is. They in the mark scheme, they went with this. They liked the brackets, but I can tell you that this would be just fine unless they purposely tell you in the question they want it in that exact format, which they didn't. The penultimate line would be enough. Right, now this one is called the difference of two squares. Notice how 9 is a square number and so is 4. The trick is, in your double brackets, you square root the 9, which is a 3. You square root your x, which is x. And we do the same with the y. So the square root of 4 is 2. Square root of y squared is y. The trick is we write this twice. In one of the brackets you add. In one of the brackets you subtract. Job done. Difference of two squares is the name of that topic. Okay, here we got to bring the fractions together. So the common denominator is going to be 8x for both, right? Because numerically the lowest common multiple is 8, but you've also got to think about the denominator on the right being x. So they both got to also have x in the denominator. Meaning, multiply the first fraction top and bottom by the letter x. So left-hand side becomes 7x. Take away the right-hand side, if we times over top and bottom by 2, becomes 2x plus 6. Now, you are subtracting both the 2x and the 6, so it becomes 5x minus 6 all over 8x. And that's it, we're done. That's the answer, number 17. Oof, this is a beast. We got to write a in the term. Basically, we got to rewrite a only using the letter y. No x is allowed, if you look at that, right? No x's, only y's, that's it. So, what we need to do with a is we'll rewrite it, but instead of writing 3x, I need to write 3 of all of that. 3 lots of 7 over 4y minus 3 with a minus 7 afterwards, right? So look, we've got one mark in. Let's multiply out that bracket on the denominator. So 3 lots of 7, that's 21 over 4y minus 3, take away 7. Now, what I'm going to do with this fraction is I want to bring it in the same fraction as here. So I'm going to rewrite 7 by writing it 7 over 1. I can times the top and bottom by 4y minus 3. Right, so I'm timesing the top by 4y minus 3, giving me 28y minus 21. And the bottom becomes 4y minus 3. So what I can do now is rewrite it. 14 still at the top. I haven't done anything there. 21 over 4y minus 3. Haven't done anything there either. But from that, I'm going to take away 28y minus 21, all divided by 4y minus 3. I can bring these fractions together on the denominator. So let's do just that. 14 over, 21, take away 28y. But because you're taking away a negative, it becomes plus 21. A lot of people are going to fall for that trap there. Don't be that person. All over that denominator, 4y minus 23. Okay, 4y minus 3, sorry. So look, we can tidy up the sort of denominator. It's going to be 14 over 21 plus 21 is 42, take away 28y, all divided by 4y minus 3. I might run out of space here. Now, this bit we're going to do keep flip change. So you're doing 14 divided by that fraction. So what you can do is keep flip change. We love a bit of keep flip change. So 14 times the numerator instead, divided by the denominator. You know what? Your life is going to be easier. What I'm going to do here is, I've noticed that the bottom of my fraction involves a little bit of times tables. In fact, 14 is actually, I can factorize 14 out, can't I? This would be 3 minus 2y. So the reason I've done that is just, look, I can cancel out my 14s now. That's really, really nice. So actually the answer now is simply 4y minus 3 over 3 minus 2y, which is, they want the y at the front on both terms. So let's make them happy. 4y minus 3 on the numerator, minus 2y plus 3 on the bottom. So there we go. We've got it in the form they wanted. Let me confirm that with the mark scheme. I'm feeling pretty good about it, but let's see what they've written. 4y minus 3 over 3 minus 2y. Oh yeah, they in the mark scheme, they actually put it. This is what they've got in the mark scheme. I switched around the denominator just because that's how they phrased it in the mark scheme. But don't worry if you stopped here, that's good enough. Brilliant. Right, we've got a couple more to go. Let's speed run this. Let's not waste time. Number 18. Okay, right. Few things we're going to do. Everything's in a root 32 form. Okay. Pretend you don't know that. What we're going to do. Right, so root 2 becomes 2 to the half. So this is 2 to the 5 over 2. This is 12 over root 2 minus 1. Okay, how are we going to do with this? So I want to rationalize the denominator on the left. So we'll times the top and bottom by root 2 minus 1. We're going to times it by root 2 plus 1. Top and bottom. So this is going to become 12 root 2 plus 12 over, well, if we do the double bracket, root 2 minus 1, root 2 plus 1, that times that would be 2, that times that plus 2, plus root 2, that times that minus root 2, that times that minus 1. The plus and minus root 2's cancel out. 2 take away 1 is 1. So it's all divided by 1. Lovely jubbly. So this first bit here is nice because it is simply 12 root 2 plus 12. And this bit on the right is 2 to the 5 over 2. Now, I think that was probably the wrong direction, but we can think of this as root 2 times root 2 5 times. Yeah, that's what root 2 to the power of 5 is. Now, what you can do to make your life easier is we can bring this all under 1/3. So when you times, this is allowed, right? You are allowed to multiply thirds by one another. So this becomes 12 root 2 plus 12 minus 2 times 2 times 2 times 2 times 2. 4, 8, 6 is the root 32. Cool. Now, I'm staring at this thinking, right, well, look, I've got my 12. That bit I'm happy about. I need to think about this now. So look, 12 is the same as, let's think about this, square root of 144, root 2. So we can rewrite that first bit as the square root of 288. But because this question involves root 32, let's break up the root 288, right? This is the same as 32 times by something. It has to be, right? So how many 32s go into 288, you ask? I need to work this out. I have to do a bit of division, aren't I? But yeah, bus stop doesn't really doesn't work here, does it? So there's a little bit of work in my head. I'm thinking, well, look, I can make this easier by halving them both. I can halve it again, which would be 72 over 8. And 8 goes into 72 9 times. So it's the same as this, root 288 is the same as root 9 times root 32, which lo and behold is 3 root 2, isn't it? 3 root 32, sorry. So look, I've got all of these workings, plus 12 root 32. Now, take away root 32 is taking away one lot of root 32. So your 2 and your 1 becomes your 2 root 32, and obviously the plus 12 at the end. We're done. We proved it. Good stuff. 19. All right. How many more we got? Crikey, 2 more. We got this. Right. Last but not least. I may have to put this up. Okay, right. For question 19. Looking at this question, you got to ask yourself, right, what am I noticing here? So the question says, write x in terms of n. And we've got all of these numbers here. Now, I'm looking at 18, 27, 6, 9. They're all numbers in the 3 times tables. Let's try and work this out, right? Let's try and rewrite all of this in terms of 3 as best as we can. Because look, at the end, you want it to be in 3 to the power x. It makes sense to bring out as many 3s from the fray as possible. So, for example, you could say that the 18 at the front is 2 lots of 3 times 3, which is the same as writing 2 lots of 3 squared. Now, the square root bit here, the root 27, well, the square root part, you can square root numbers by sort of raising them to the power of 1/2, can't you? And also 27, the thing inside, would be 3 cubed, right? 3 times 3 times 3 is 27. These are not by coincidence, right? They are choosing these numbers deliberately because that's what the examiner wants you to do, right? Now remember, obviously we're also raising this to the power of 4 n plus 6. And this is all being divided by, well, 6. I'll try and do these in different colours so you follow. The 6 at the front there is the same as 2 times 3. And the 9, you guessed it. Oh, what colour am I going to use? Yeah, green. 9 is 3 squared. Do use brackets here. You know, if you're not sure, should I put in brackets or not? Usually the answer is yes. And then obviously to the power of 2n plus 8. I know I've used red twice, but it's totally fine. Okay? So basically, we're going to tidy all of this up now. You'll notice that because there's no addition, obviously besides the powers, but think of it as we're multiplying all these terms by one another. There's an awful lot of cancelling that can go on here. For example, the 2's on the top and bottom, because they're division, think of the fraction as dividing. 2 divided by 2 is 1, so really we just cancel it out. And likewise, one of the 3's on the bottom can cancel the squared out, right? So it now becomes, instead of being 3 squared, one of the 3's cancelled out. It's only 3 on the numerator now. Brilliant. So where are we now? On my new line of working, well, I'll keep that 3. I'll write that first. Now the bracket, what's inside the sort of orange bracket, you know, when you've got 2 powers like this, you can just multiply them, right? So this can be 3 to the power of 3 halves. And then we've got the sort of purple power on the outside. 4n plus 6. And this is all being divided by, well, you know what? I'm going to times out. So we are multiplying the 2 by all of the 2n plus 8. So you can treat that as sort of expanding brackets. We're multiplying the 2 by the 2n plus 8. So on my numerator, I'll have 3 bracket 4n plus 16. Right? New line of working. Why not? So I'm also going to do something similar now for the purple bracket on the top. I'm going to multiply 3 halves by 4n plus 6. This gives you something quite nice. So 3 halves times 4. Well, 4 divided by 2 is 2 times 3 is 6n. And 6 divided by 2 is 3. 3 3s are 9. Okay, so in the numerator, the bracket's going to be 3 to the 6n plus 9. Your denominator, we worked out already, was 3 bracket 4n plus 16. But not forgetting about the 3 here at the front. Remember, we've still got to multiply this in the numerator. Now, if a number hasn't got a power, we can put 1 in its place. So let's think about it. We can add the top powers now. We've got 3 to the 6n plus 9 over 3 to the 4n plus 16. Because we're dividing, we can subtract these. So you want to do 6n plus 9, take away, and use brackets here, because it's not just 4n, I forgot the end there, but it's also taking away the 16. So 6 take away 4, 2n, and 9 take away 16, negative 7. You're going to get 3 to the 2n minus 7. Remember, this was what we were trying to work out as 3 to the power of x. And at this point, clearly the powers are the things that are equal, right? We're raising both 3's to the same power, so x, therefore, must be 2n minus 7. I'm just going to confirm that my mark scheme here. 2n minus 6. Where did I subtract wrong? Of course, because I forgot to add the 1 from earlier, didn't I? So this should have been I should have added the 1 and the 9 together to make it a 10. Apologies. So this, silly me, does change the number at the end. So 10 take away 6 is actually minus 6. So I messed up there on near the very end. So apologies there. If you spotted that before me, good on you, right? Yeah, but the correct answer is 2n minus 6. Oh, I can't believe I did that. Nightmare. This goes to show you that even maths teachers, I still feel pretty confident about getting a grade 9, but less confident of getting 100% because all my working's there, and that's the important thing. All right. So this is tricky because it is we're factorizing, but annoyingly, it's completing the square. It's completing the square, but with algebra instead of numbers, which sort of makes it a little bit more of a challenge. Personally speaking, I feel more comfortable always putting the square term first, the term with x second, followed by the letter last. Don't worry if you're not like that. It's not a big problem. Okay, so if you noticed about the brackets, the way they want the answer, the x coefficient, you'll notice, is positive. And currently, ours is not, it's minus q. How can I fix that? Well, look, I'm going to start by factorizing out. Notice how in this bracket, there's no number in front of x. So what I want to do with those first two terms, the minus qx squared and the plus 12x, is I'm going to factorize not just q, I'm going to factorize out the letter negative q. Because if I do that, the first term I write is x squared, and the second term I'll write is negative, because I need the minuses to cancel out, 12x. But I'm going to have to divide it by q, right? Because if you think about it, if you expand this out, you would go back to getting 12x and plus 12x and minus q squared. Fair enough. So what I've done is I've just factorized the first two pairs. Now, the way completing the square works, let me give you an example. If I asked you to complete the square on x squared plus 6x, you'd say to me, well, look, you always halve the number in front of x. So you'd always write x plus, so you've dropped the power for the x, plus 3, and then square it. And the reason this is because if you multiplied out the double bracket, you'd get x squared, nice, I wanted that was there. You'd get your 3x and your 3x, which gives you 6x. Good, I wanted that also. But then you get this extra 9 at the end that you did not want. So we do have to make these things equal, we have to say that, look, they are the same, but you would have to take away 9 from the second one if you wanted to write it this way. Okay, so we're going to do just that, although it's going to be a little bit more challenge because of the algebra, the Q here. So following the same rules, so obviously my bracket is minus 12x over q. Remember, what I do in brackets is I drop the power for the x, and I need to halve whatever's in front of my x term. So in this case, half of minus 12 over q would be minus 6 over q in brackets squared. Now, the thing you take away, just like in my earlier work, the 9 is not it's not a coincidence. It's always this squared, your plus 3 squared. You take it away, right? Because plus 3 is what gives you the 9, and minus 9 cancels that out. So I need to take away whatever this squared would give me. So in brackets, and yes, there is a reason behind this. If I square this, I would get 36 over q squared So that I need to take away. I need to take, because that, if I squared it, I'd have that as extra. I want to take away 36 over q squared. So minus 36 over q squared must go on the end. And yes, it is negative. I know there's a minus sign in the powers. When you square a negative or you square a positive, you always get a positive out of it. So we always take away when we complete the square. And remember, this is all outside my brackets. I have a negative q. I haven't forgotten about that. And of course, I've not forgotten about the plus q on the end either. Let me just put a little line there to just separate my working. This is the main work. I probably should have written it further to left, but never mind. Right, so all we got to do now, we've done most of the hard and heavy lifting. We just got to do a bit of tidying up now. So we'll multiply up the purple brackets first. So I'm going to do these times this. So I'm going to get negative q, x, take away 6 over q squared. Because I'm timesing the whole bracket by negative q. But don't forget, I also want to multiply negative q by the negative 36 over q squared, which would give me plus 36 over just q, right? So the q on the numerator cancels out with one of the q's on q squared, so that's what you get. But obviously adding q afterwards, because the brackets now ended, I can just write q at the end. How far are we away from getting it like this? Well, express each of A, B, and C. Huh. Why have I got a feeling I've done something wrong here? Oh, this is not good. What have I done? See, I've got this far. Now have I made a mistake somewhere? See, I think I made a mistake by factorizing, because if I multiply this bracket out, I wouldn't get 12q, would I? 12x, sorry. So this is a real head scratcher. What have I done wrong? So I factorized out the q. No, actually, I think we're good. Yes, I am good. The algebra just bamboozled me for some odd reason. I think I'm good. Apologies for that little sort of freeze there. It just doesn't look like the way I want it. So, obviously, when the algebra gets this complicated, you do sort of start second guessing yourself. So let's put this in a form that they want. So I'm just looking at the original answer. It did want that bit on the end, which currently I've got here at the front. So I've got minus q. I'll put this at the end because that's sort of how they want it formatted. I'll move this to the right, so this will go on the end. And at the front, I've got my letter A, which is all of this. Now, in my head, I'm thinking, do they want this as a single fraction or not? We'll talk about that in a minute. So, look, I know I've changed everything to green now, but this is purely just to show you that this is my value of A. You know, I was expecting it to be a nice whole number. Just to color code it and keep things nice. We've got why have I written C there? Not sure why. But I've got, yeah, my A at the front, which is the 36 over Q plus Q. I've got my minus Q here, which is my letter B, if you will. And then at the end, I've got my C, which we said was -6 over Q. Okay, so yeah, this is tough, isn't it? So we've got my A, B, and C. Lovely stuff. I know I froze earlier. It's a bit of a nightmare when that happens. But my only question is, do they want the value of A to be written as a single fraction? Let's read the question. I don't think so. I mean, I'll look at the mark scheme in a minute. Do you know what? It will look nicer. This might be an optional step. I'll look at the mark scheme in the end and I'll talk through it. So I'm pretty confident that probably will get you full marks for using this as your value A. But a nice little touch is that we bring the fractions together. So what I mean by that is if you multiply Q, treat Q as a fraction Q over 1, which is fine. If you times the top and bottom by Q, you would get Q squared over Q. And the benefit of this is you can sort of write it as one single fraction. Now, I'll look at the mark scheme in a minute and see if they wanted it either that way or that way. But yeah, let's write stuff on the answer line now. So, do you know what? Let's go with this first. So A is 36 plus Q squared over Q. Or I don't know. No, it's not a good habit to write all. Always commit to one answer, guys, because if you write two, the examiner will always give you the least scoring mark. B is Q, because you don't need the negative sign because they've already included it in the question. So don't include this negative here because that was part of how they phrased it. So just write Q. I know it's minus Q in my working, but they want just the letter. And the same thing for C, right? Because in your bracket up here, you'll notice there's a little negative sign. So don't put the minus in front of the 6 over Q. But that is it. Let me check the mark scheme in front of me. Again, I'll post this with the answers. You can have a look through. And of course, my laptop has locked, so I will unlock it. It says a totally different answer. How did I mess this up? Hang on. Let's review. So they have said A is 6 over Q, which is not what I'm getting. B is A over 12. Q over 12 for B. And C is 12 over 2Q. Now, interestingly, did I make a mistake somewhere? I don't know. So I'm looking at the working here, guys, and I will post this. They have the good news is the green part of my work. Sorry, the purple part here is correct. So this they've written the same. Yeah, no, we've got exactly the same thing. So not sure. Wait, hang on a minute. Ah, wait a minute. I'm trying to work out the mark scheme here because it's really racking my brain. Um, So I can confirm that this one is 100% correct. This is the same. They've in the mark scheme they've written 12 over 2q, but obviously I prefer mine because I've actually cancelled out the fraction. So either of those would get you the mark. B is simply q. Again, this they also seem to agree with me, so that's not a problem. The problem is they've written a is 6 over q, which actually goes against. It actually goes against their mark scheme. So I'll explain what their mark scheme. And this is why I sort of hesitate yet again. I am sorry, year 11. In their mark scheme, I'll show you what. I'll show you exactly what they've written on their final line of working. They've got minus q over x minus 12 over 2q squared plus 144q over 4q squared plus q. So look, bits that I agree with are obviously B is Q. I agree with this. This bit, which is if you look at the question, the value of C, which look 12 over 2Q is equivalent to 6 over Q. So this bit I agree with. Now, for some reason, and I'm trying to work this bit out, how on earth is this bit at the end, which I'm assuming is their value of A, how is that 6 over Q? That doesn't work. The furthest you can go is either you write it like that or the way I've written it. I mean, the mark scheme says 6 over Q. I will leave it here because maybe I made a mistake somewhere, but I am probably going to disagree on the mark scheme. Again, these aren't official GCSEs, but they are still designed by Excel, so they do sometimes make mistakes. It could be me making a mistake, but I'm going to leave it as that. Don't know why they've written it as 6 over Q. I can't wrangle my head there. So I'm going to stick by my guns on this and say that's the value of A. B and C, we both agree with mark scheme. How did you get on? So, hope you did well. This was a bit of a killer last question, but did you rise to the challenge? Let me know.